Number 22. Find the limit as x approaches infinity of y and the limit as x approaches negative infinity of y. So we have y is equal to parentheses 2 over x plus 1 and then times 5x squared minus 1 over x squared. So I need the limit as x approaches infinity, and I'm just going to say of y instead of having to rewrite the whole thing. So if I put in infinity for x, what's happening? Or what do we notice?
So if you put like a big number in for x, you mean?
Yeah.
It's the same thing. So
It's staying positive.
it would stay
Like it's
positive.
getting bigger.
Okay. Yeah, so it's gonna stay positive. What do I care about?
The
biggest
biggest
exponent.
Yeah, so in this one, all I care about, I can ignore the minus 1 because realistically, minus 1 out of that whole thing isn't going to change anything. And then I've got a 5x squared over x squared. So how do I need to, what would I do with that?
Factor.
Like take
We can
take out
we
that
can take the square root.
Get rid of x squared. Okay, is kind of how I'm thinking about it. So basically this is going away.
Oh, you can just do that.
You can just
'Cause it's
cancel it.
multiplied?
Yeah, this is multiplied.
That's right.
So I'm left with 5 out of that one. And then what about this one? What's 2 over some really big number?
half that number. Wait.
2 divided by some really big number. Not some really big number divided by 2.
Really
Yeah.
small.
Gets really small, close to
0.
0. 0 plus 1 is
1.
1. So 1 times 5 is 5. And then the limit as x approaches negative infinity of y. So basically some really big negative number. What's happening?
See if you put
It's
well,
staying the same.
yeah, it would still be the same.
Well, yeah.
Yeah. It's going to be the same, okay, because 2 over negative 500 or, whatever, that's negative, but it's a negative number that's almost 0. So adding 1, that's still going to be positive. So that's still going to be 1. I mean, basically. We're approximating, but roughly 1. And then 5x squared over x squared, because again, we can ignore the minus 1 since it's not going to change anything. The x squareds are going to cancel and leave you with 5. So in this case, they happen to both be the same. Let's see. Let's look at 24. Y equals 2x plus sine of x over x. And so, same instructions. The limit as x approaches infinity of y.
So should you like factor it first, or just like plug in big number for x?
I can't really factor.
Can we
But I
split
can
it up?
see what kind of happens if I plug in a really big number for x. So, plugging in some really big number, what do I get?
I don't know. I gotta do this.
Doesn't matter what really big number we
Doesn't matter what really big number we use now.
Let's just say
Without even doing anything, just do what the sine of 500 is.
Yeah. So it's like less than 1, so it's not
Well,
really gonna.
yeah. So sine of 500, sine of x is like
It's not really gonna affect
it's
it.
not gonna affect it.
Right, because it's less than 1, so it's like adding 1 isn't really going to do anything. So we can kind of just disregard the sine of x. So we're really just thinking about 2x over x,
so it'll just be
basically.
2. Yeah.
So it's just going to be 2. So if you're ever not sure, you can always do that and check it and see what happens. The limit as x approaches negative infinity of y for the same problem is what?
Also 2.
Yep,
Yeah. Also.
for the same reason. Okay. Let's see what's next. We did 12 yesterday, right?
We sure
We did not.
not. We sure did not.
I don't want to do that.
Might be a distraction.
But we did a sandwich theorem problem, right? Number 10.
Sandwich.
Okay.
theorem?
Yes. We did.
Yeah, we
What's the
did.
sandwich theorem?
This one. The one where you pick two things that you know and you compare
Can
it.
we just
Can we do
another
another
now?
one of those?
Huh?
Can we do it now?
Yeah, that's fine.
Sandwich.
So 12 is. I thought I had gone and done this one yesterday because I saw that it was later, but I guess I didn't. As the limit as x approaches infinity of sine of x squared over x.
I know. What do you mean? You put it there.
Want me to hand them to you, or just, I can just hand them to them? It's their order forms for them.
Oh, you can give them to him if you want.
She got such a big class today.
I'll have more of them I was gonna say I'll have more of them at the end of the day, but I won't be here.
Pass that one to Christian for me. I'll get the top one. You're welcome.
Thank you.
Thank you, guys.
What is this?
Live touch pictures tomorrow. All right, so for the sandwich theorem, we are going to compare this to something that we know because we don't know what this is. It looks kind of like something that we know just because we were told this is whatever. But we don't know off the top of our head what it is, so we're going to compare it to something that we do know. So we're going to treat this as, since this is over x, we're going to do this as negative 1 over x is going to be less than or equal to sine of x squared over x is less than or equal to 1 over x.
Will it always be 1 over x?
So it's whatever this is. So I think we had one the other day that was x squared on the bottom.
Yes.
And so you would compare it to...
Oh, so like you want the denominators to be the same.
So, basically we're looking at still the limit as x approaches infinity. So as I put a really big number here on the bottom, negative 1 over 500 is what?
Like really close to 0.
Okay, really close to 0. 1 over 500 is
Really close to 0.
really close to 0. And so we're saying that in between that then, that should also be 0.
Okay.
Are they all like
Are they all gonna be like
0?
I'm not going to say always and forever, but pretty much in this section, yeah. For the sake of these, it is.
You have to get over it.
All right. 27 through 34 says to find the vertical asymptotes of the graph of f of x. Describe the behavior of f of x to the left and right of each vertical asymptote. So basically, what happens is it gets really, really big and really, really small. Basically. So, 28, we have f of x is equal to x squared minus 1 over 2x plus 4. So, do we remember how to find vertical asymptotes?
No. It's not the Bogo-Basco-Latman, because that's horizontal asymptotes. Oh, isn't it? Oh, wait. I got this. It's like
What? Let me ask it this way. What makes a graph undefined?
if
the
there's
bottom
a
is
0
zero.
on the bottom.
So how do we find a vertical asymptote?
Oh, the
Say
horizontal
equals
line.
0.
Wait, no.
Huh?
Just set it equals 0 and solve.
Set what equal to 0?
Right, if the
Fine.
bottom's equal
Yep.
to 0.
Set the bottom equal to 0 and solve. So 2x plus 4 equals 0. 2x equals negative 4, so x equals negative 2. So if x was negative 2, there would be a problem. So I have a vertical asymptote at x is equal to negative 2. Don't know why this is so blurry today.
So, what would have to happen for there to not be a vertical asymptote?
If it was equal to 0.
Basically, vertical asymptotes occur anywhere that the function would be undefined. So, typically, the only scenario we ever see with that is the denominator being 0. So, some trig functions have them as well. Tangent has one. Secant and cosecant have them. Cotangent might also. It's the dotted lines that go up and down. Alright, so then it says, describe the behavior of f of x to the left and right of each vertical asymptote. So basically, what happens as the graph gets really close to negative 2?
Like it's getting
It gets
smaller.
close to it, but it doesn't touch negative 2. It doesn't.
Yeah, so basically, essentially what we're looking at is the limit as x approaches negative 2 from the right and the limit as x approaches negative 2 from the left of f of x. So from the right, you'd have something like negative 1.99999. And so on the bottom, what would that give us?
What do you mean?
It's like if you put in negative 1.99999 for x,
Bigger,
basically
like
positive or negative.
positive. No. Yes.
Okay, it's going to be positive, and what is the number close to?
But if
Like,
you plug
Close
this,
to 0.
Hmm? Yes, it would be close to 0. It's going to be like 0.00 something, probably. Ballpark. So then if I plug in negative 1.99999 and I squared it, that becomes positive, and it's almost what?
4.
It's almost 4. Minus 1 is 3. Divided by something that's almost 0. What does that give us?
0. No.
Something that's almost 0. So dividing a number by a really small number is the same as doing what?
Multiplying by a really big one.
So it's going to end up giving us a really big number.
So,
Graph that on your calculator and we'll look at it.
are we just saying if it's going to infinity or negative infinity?
Yes.
Okay. That's easier to understand. Because it's going to infinity, right?
Yeah. I'm just trying to help you see what we're plugging in to see that. But it's usually, I think y'all are more visual people like me, so probably seeing a graph is going to help a little better. So basically, as you get close to -2 from the right, what does your graph look like?
Okay, it's not what mine looks like.
Okay. So as it gets close to -2 from the right, so it's your top right graph there, what does it look like is happening to y?
Going to infinity.
Going to infinity. How about the one from the left?
Going to -infinity.
Negative infinity. Josh, is that not what yours looked like?
It's much easier one.
I don't understand why it does that. That's super weird. All right, let's look at another one. 30. F of x is equal to 1 minus x over 2x squared minus 5x minus 3.
So we go to steps above equal to 0.
Yep. Any recommendations?
Why
Get
would-
wait, should you move the 3 over first? Or no?
No.
Or should we factor it?
We should factor it first. Because if I move the 3 over, I'm not going to be able to solve it correctly.
So we have 6 and -1.
-6 and 1.
-6.
So 2x squared plus x minus 6x minus 3. Take out an x. 2x plus 1. Take out a -3. 2x plus 1. So x minus 3 times 2x plus 1. So I've got x is equal to 3, or x is equal to -1/2. So now I have to look at these limits at both of these spots now. Okay, so I'm doing a left hand and a right hand limit, okay, at 3 and at -1/2. Okay, so I would say probably the best thing to do in this case is just graph it to do this. Since you have multiple, I would graph that function there. So we're going to have the limit as x approaches 3 from the right of f of x. The limit as x approaches 3 from the left of f of x. The limit as x approaches -1/2 from the right, and the limit as x approaches -1/2 from the left.
So, if I'm reading this correctly, as it is approaching 3 from the right, what? It's negative infinity?
3 from the right.
Yes. Bless you.
Thanks.
And as it is approaching 3 from can the 3 from the 5, well,
It's
yeah, well I guess as it approaches the 3 from the left, it's also negative infinity. But yeah, but it also goes up too.
Which is infinity.
Yeah, I guess.
Yeah, it's supposed to be positive, but I don't know what the graph looks like.
Yeah. Yeah.
it looks like those heart monitors or whatever.
What?
It's supposed to be infinity. All right, and then negative 1/2 from the right.
Negative infinity?
Yep. From the left.
Infinity.
Yep.
So how are you supposed to like figure that out without having to graph it? Because like there's no way I would have been able to. I
Basically,
have
just
to
typing
see- I
a
have to
number
see
in
that.
that's really similar. So, like, I would do something like, so 3 from the right, I would say, like, 1 minus 3.0001 over 2 times 3.0001 squared minus 5 times 3.0001 minus 3. And you would just have to do it like that.
Okay. And that would give you a big negative number, and that's why it would be negative infinity.
Yeah. Because, you know, this top number is negative.
Right.
Bottom number is going to end up being positive. And you can know that that's going to be like a big number over a really small number probably. So it's going to end up being infinity, and it was negative because of the top. So I usually just take a number and plug in something that's pretty close to it, that's slightly bigger or slightly smaller than it for the left and the right, and then I do that. If I don't like look at the graph. So, but most of these are, I mean, they're going to infinity or negative infinity. So as long as you can figure out what the sign is, you should be able to figure it out. All right. Next thing is find a power function in behavior model for F. Identify any horizontal asymptotes. So we've actually done this before. You probably just don't remember it. 40 is f of x is equal to negative 4x cubed plus x squared minus 2x minus 1. So a power function in behavior model, it's a mouthful, is whatever the highest powered term is.
Okay.
If it's a fraction, it's the highest power on the top and the bottom, and then you reduce it down. So, for this one, it would just be negative 4x cubed.
Oh, that's it.
Yeah.
Yeah, I remember.
Does this have a horizontal asymptote?
Yes.
Bobo, Botno, Bosco?
I was really just guessing. So
Bobo, bigger on wood, but there's no bottom.
Okay, well, if there's no bottom, there's technically a...
1.
1. Okay.
So it's
Bigger
bigger on top.
on top.
No, there's not.
No, there's not. So there's no horizontal asymptote. Don't just leave it blank. I'm going to assume you didn't do that part. So always make sure you say none. (42) f of x is equal to 3x squared minus x plus 5 over x squared minus 4. So my power function, I can't, you know what I'm trying to say. Power function thing is going to be 3x squared over x squared, okay, because that's the highest power term, top and bottom. But I can reduce that, so it's actually going to be 3. And then, do I have a horizontal asymptote?
Yes, it's
Yes.
0. Wait.
Bobo,
It's
Bosco, both the same. Use the coefficients.
3.
You would use 3.
So y equals 3. And remember, it's y equals because a horizontal asymptote is a line. So yeah, both the same, use the coefficient. 44. f of x is equal to negative x to the 4th plus 2x squared plus x minus 3 over x squared minus 4. So what's the power function?
Negative x 4.
There's no horizontal
Over
over
x
x.
squared.
Oh,
asymptote.
so
You
we
still
have
gotta
to.
do that.
It's
So,
the biggest on top and the biggest on the bottom
Top and
over each other. So that
And
reduces to,
negative x squared.
alright, and then horizontal asymptote.
No, there's
No, there's not. Bigger on top. No, there's not. So none.
oh, I was just confused by the first one because there was nothing on the bottom. Right?
And remember, if it's bigger on bottom, it's
0.
y equals 0. My gosh.
Okay, good for you.
It scared me. I was like, what's happening?
Well, I'm in the period anymore. I'm not tired, so. Outstanding.
Alright, we're gonna look at these last two here. Find a simple basic function as a right in behavior model and a simple basic function as a left in behavior model for the function. Y equals x squared plus e to the minus x. So the right in behavior, do as REB. So I would graph this.
Okay.
And we're doing left in behavior also.
Have we done this rather problems before?
I don't know about that, Nathan.
What'd you say?
What in
What did you get?
what
Why
incarnation?
is 0, 0?
Hold on.
That's the y equals 22,000.
Wait, do we do Zoom 6 or Zoom?
I did Zoom Fit because you can't see it in Zoom Standard.
Zoom, yeah.
All right, now what do we know about a exponential graph? Specifically, e to the minus x.
What? E to the minus x.
Yeah, what does that graph look like?
Looks like a decay.
Okay, a decay function. Okay, so e to the minus x does something like this. Okay. And then x squared does what?
I don't know.
Something like that, right?
Yeah.
Okay. So the left end behavior model, we would be using this. Okay, because at the left, this is going.
How do I zoom out so I can see?
You're just going to go change your window. Just hit window and then change it, make it bigger.
Change the scale.
Yeah. Well, no. Change your window. Like change your Y, min, and max. So it won't always be that they're going to be two different ones, but e to the minus x, that can only be your left side. So when you have them being added together, you have see if I can change my window so I can show you what I'm trying to show you. So I changed, oh, you can't see it. I changed my window a little bit here. So this left side of my graph is the e to the negative x. This other part is it starting to go up for the x squared part. So the left end behavior is going to be e to the minus x. Right end behavior in this case is going to be x squared.
I'm still having difficulty zooming out. I don't know how to do it.
So hit window.
Yes.
And then I left my x min at negative 10. And then I made my x max 50. And then I changed my scale on x to 2. And I left y as it was.
And then, so I just hit.
And then hit graph.
Oh, hit graph.
If you hit zoom and then something else again, it's going to reset it.
That's what was my problem.
Okay, well I can't even see the graph.
I can
It's
see
giving
that
me an
now.
error.
I can.
You can't see the graph at all.
It gives me sending its error every time. So like weird, but that's what it is.
Yeah, I know. I hit go to. No. Yep, negative sign, not minus sign. Let's see. Okay, I think that's where we're gonna stop. I wouldn't stress about these ones too much. I just kind of wanted you to see one of them. I'll give you one to like try that's similar to that, but don't stress about it too much. All right, so your problems then are going to be I'm gonna warn you, it's kind of a lot. 1, 5, 9, 13, 15, 21, 27, 29, 39, 41, and 45. So we only have like 10 minutes left today, but tomorrow will be you can work on this some and review for the quiz that's on Thursday. That's this
The
class,
quiz-
right?
The quiz on Thursday is covered in what section?
Just 2-1 and 2-2. So the limits and then the limits at infinity are involving infinity. And then after the quiz on Thursday, we'll start notes for 2-3, which is on continuity.